right, guys, you want to say hi to your 8th period classmates? That's it?
Hola.
Hola. All right. Anybody particular you want to say hi to?
Who's in there?
Everybody.
Hello, everybody.
Ty says hi to his mom. Oh, we're doing this for us. All right. Okay, guys. Everybody good? All right. Here's your warm-up. This will be posted online. Okay. So for your warm-up, it says, my turn. Divide using synthetic division with no calculator. So how do you do synthetic division? You set this one, 3x minus 2, set it equal to 0. Okay? You will have a test coming up after this lesson and one more. So, solve, you're going to add 2 to both sides, cancels out, so you got 3x is equal to 2. Divide both sides by 3, so x is equal to 3. This is your divisor. That's going to be your divisor. Okay? All right, so we're going to come over here and use our paper and do 2 divided by 3. Just like that. Now, let's take a look at our dividend. 4 is what we're going to divide everything by. 4, 3, 2, 1, and a constant. So they're all in order. So let's write our coefficient. 3, leave yourself some space. 4, -4, -3, -9. Remember, you can pause anytime you like on this video. Okay? So if I were you, I would probably pause right now. You try it first, and then you would come back. So I hope you guys have done this on your paper. All right, bring down your 3. Okay? You're going to multiply 2 over 3 times 3. I hope you're doing this because it should be in your notebook. 3 divided by 3 leaves you 1. 1 times 2 is 2. Some of you guys are subtracting. Make sure you always add. 4 plus 2 is 6. 2/3 times 6. Okay? 6 divided by 3 leaves you 2. So 2 times 2 is 4. You add. -4 plus 4 is 0. 0 times anything is 0. -3 plus 0 is -3. 2/3 times -3. -3 divided by 3 leaves you -1. -1 times 2 is -2. Therefore, your remainder is a -11. Okay? So, you multiply and you add, and you repeat the column. Multiply, add until you get to the very end. How you have it written is very important. Make sure it's orderly, because otherwise it's going to mess you up. All right, so you have 3x to the 4th. That means you took 1 away right here. So now what do you have left? 3x to the 3rd plus 6x squared plus 0x minus 3. And there is your remainder. So let's go ahead and write this real pretty. 3x to the 3rd plus 6x squared. You don't have to write the 0. Minus 3, and your remainder is minus 11 over your divisor, which is 3x minus 2. And there you have divide using synthetic division. Okay? All right. Take a moment. If you don't know this, you need to learn this. It will be on your test. And it will be a no calculator portion. So make sure you know how to do it. Next week. It'll be next week. That'll be your first 100-point test. You'll have a little quiz this week. All right, guys. Now we're going to head into identifying the key characteristics. You all should be on page 1. I printed them out for you. It should say page 1. Okay? This one is page 1. Now, I'm going to see if I can make this just a little bit bigger. A little bit bigger. Okay. Now, if you guys will notice, I did not give you guys an equation. I did not give you a function for this. So everything you do is going to be based on the graph that's in front of you for this problem. But the others, you are going to use a calculator and you are going to estimate, okay? And I'm going to show you guys how to do it. We're not going to find zeros in a way that it's a perfect zero, like a square root of 2 or something. I'm going to let you guys use a decimal just to find it. But when we get into quadratic, you are going to find me the exact answer. But for this, we can just estimate based on the graph. Sounds good? All right, so I want to teach you guys this first. All right, your domain. So before we start, let's name this polynomial. What is the name of this polynomial? Take a look at your end behavior. How many places is it going in the opposite direction, or is it going the same direction? It is opposite direction, so it's got to be an odd function, okay? All right, now take a look at your turn. So I'm going to go ahead and teach you guys this part. Turning points. Look at how many places it is turning. I start here. I hope you are listening, because this is just all analyzing a graph. You're cutting across. This is a cut. You cut across right here, and you cut across right here, okay? So there's 3 cut. You're cutting across the x-axis. So your degree is either 3 or more, right there, because you've cut across the, so you got 3 x-intercept. 1, 2, 3. But look at your turning points. It's turning right there. There's 1. It's turning right there. So how many times is it turning? 2. So there are changes from positive to negative, negative to positive. If your turning point is a 2, your degree is usually 1 more. So if your n is a 2, what is the degree of this one? 2 plus 1 is 3. So this is a third degree. And what is it called if you have a third degree? It is called a cubic function. And what's a cubic function? It is x to the 3rd power. That's a cubic function. So look at your turn. 1, 2. How many turning points? 2 turning points. If it's 2 turning points, it's 2 plus 1. It's always 1 more. So that is opposite direction. That tells you it's going to be an odd power. You see how they're going opposite direction? Your end behaviors? It's not pointing in the same direction. So that tells you it's 1. It's got to be an odd power. And you got 2 turns. 1, 2. So think of it like 1, 2, 3. So it's a cubic function. Do I have to know what that function looks like? No, not for what we're doing right now. Okay? You just need to know it's to the 3rd power. All right. So that's the naming. You can say it's a cubic or 3rd degree polynomial. Your domain goes from left to right. And take a different color pen. Negative infinity to positive infinity. Where is this graph starting? Far. Does it start right here? No, that arrow keeps going. Is it starting over here? Is it starting over? It's starting way over here somewhere, right? So anywhere over here. What is over here? Negative infinity. How far to the right is the graph going? Does it stop right here? Does it keep going? Keep going, keep going. Where is it going? To positive infinity. By the way, your domain for every one of your function is what? Negative infinity to positive infinity. What's another way I can write this? The 2 line with an R for all real numbers. You can write it like that as well. Okay? So your domain for every one of your function is what? Negative infinity to positive infinity. Okay? It's always left to right. Here's your left if you don't know what that left is. And right over here is your right. All right. You guys see domain? You got 4 problems to do on this one. All right, let's take a look at your range. Range goes from the bottom to the top. Remember how I said about building a house? Okay? Your graph starts down here. Does it stop right here? Does it start right here in the foundation? No. Where's this? How about right here? How about right here? Keeps going all the way down, doesn't it? So where does it start for this one? It starts at negative infinity. How high? What's the ceiling on this graph? to infinity, because we don't have an exact point, right? It goes on forever. So your range is negative infinity to positive infinity. What's another way I can write that as well? All real numbers. The two line with an R. All real numbers. Okay? Have you guys done this before in Algebra 1? Not like this, but you've heard of domain and range, and you just kind of list your x value and your y value. You are going a little further in Algebra 2 because you're getting into the 0.0001, 0.0002, 0.003, 4, 5, 6. See what I'm talking about? You're not just looking at one little x value, you're looking at all the little points in between it. Okay? All right, let's look at our end behavior. Here we go. Our end behavior. All we're going to look at for our end behavior is this one right here for our left, right? Okay. You don't have to write left. You don't have to write left, but I'm going to write L for left. You don't have to write left because you can tell it's left by this right here. Limit x is going toward the, coming from what? Negative infinity. Did you guys see that? That tells you that's the left side, okay? You don't have to write left. You can just write x coming from negative infinity. If I'm coming from negative infinity, where's that graph pointing? It's pointing where? Down. Am I falling down on the left side? If I'm falling, where is it? Y is what? Negative infinity. See that right there? I'm falling left. Am I falling left? Left side, falling, negative infinity. Okay? Think of where your graph's going. It's kind of pointing like southwest, isn't it? South is negative infinity, west is negative infinity. Think of directions. All right. That's your left side. How do you write the right side? You don't have to write R. Instead of writing R, what can you write? Limit x is going toward positive infinity. Okay? So here's your left side. That's all you have to write. Let's look at the right side. This tells you this is the right. You ready? Where's your right pointing? It's rising. Where is it rising toward? Think of Buzz Lightyear. Where's it rising toward? Where's he going? To infinity and beyond. Very good. So Y is going toward the positive infinity. I'm pointing right up, right? Past the ceiling, past the atmosphere. Buzz Lightyear, he's going up. Where's he going? To infinity and beyond. Okay? Here's a hint for you. You might want to write yourself a little note. You guys ready for the note? For an odd power. That means x to the first power, x to the third power, for every function. X to the what power now? Fifth power. X to the seventh power. X to the, you see what I'm getting at? This is the answer every single time. Your domain will always be the same. It's always going to be all real numbers. Okay? You might want to make yourself a little note just to help you. Your range is always going to be all real numbers as well. Okay? Fernando, I think you owe me a quiz from last week, right? Yeah. Take it tomorrow. I need you to listen to this one. Yeah. I just remember. It's okay. Yeah. Hey, I called you out. Woo! Woohoo! Okay. All right. All right. In behavior is also going to be the same. The only thing that's going to change on the in behavior is this part. You guys ready? That one and that one might change. Because if you start it in a different direction, you start it, instead of falling down, falling left, you might be rising left. Instead of rising right, you might be falling right. Does that make sense? Because if it's a negative, it's going to change. All right. Everybody good? regarding those things. It's always going to be the same for an odd power function, okay? All right, now let's take a look at x-intercept. I'm going to move this back a little bit. You guys are just going to estimate for our purpose today, and then when we get into our next unit is when you're going to really find it. Okay, here we go. X-intercept, third power. So how many possible x-intercept can you have? 3. How many roots can you have? 3 or less. Remember? Sometimes they don't cross the x-axis, right? All right, what is this point right here that's crossing the x-axis? -1, -2, -3, 0. Did you guys see that? Okay? It is a point. You need to write it like that. You need to write it as a point, x and y. X-intercept, what is that one right there? -1, 0. Okay? Because here's your origin. What is this one right here? Not 7. Take away one of the little point, one of the line. It is 2, 0. There's your x-intercept. Okay? Why? Because this is our x-axis, correct? Just a point. Just kind of estimate it, okay? Y-intercept. How many y-intercepts are you always going to have? Just 1. What's your y-intercept right here? We're just going to pick that one. -1, -2, -3, -4, -5, -6. Almost a 7. 0, -6. If you write it like this, I'm going to count it wrong. Why is it not y equals -6? Because that is what kind of a line, or what kind of a graph? It's a straight line, right? Are we talking about a straight line? We're talking about a point, so this is a no. Don't write it like that, okay? Any questions so far? All right, so write a point. Now, your relative maximum. Your relative maximum, okay? Relative is not the highest, but it's one of the higher points. Is that a maximum right there, like a hilltop, your mountaintop? All right, this one is your absolute max. That's as high as it's going to go. But I didn't ask for that. What did I ask for? The relative max. What is that point right there? -1, -2, and then it's -1, 2, 3, -1, 4. So how many relative maxes do you have? Just 1. So it's your high point, okay? All right. Down here is your relative minimum. Oh, is it -2? Oh, I'm so sorry. You are so right. It's -2, 4. Thank you. Should I shout out your name because you corrected me? Shout out to Isaac. He corrected me. Yay! Hey guys, even 8th period don't get to do this. I'm sorry, guys. Okay, maybe next time. All right, we'll have to do this 8th period someday. Okay, relative minimum. What's your relative minimum? 1, 1, 2, 3, 4, 5, 6, 7, 8. You guys think it's -8? Yeah. And there you have all your characteristics that I want for today. We are going to do intervals later, not right now. Okay? Any question? Do you see how you're just analyzing a graph? Yes, sir. Not yet. Maybe when you correct me, I will. Okay. All right, guys. There's page 1. Let's move on. Okay. You all should be at page 2. Here we go. It should look something like this, page 2. Everybody good? Okay, here we go. All right. I'm going to draw 2 arrows. Do you guys see that right there? And this right here kind of goes up and comes down, right? But I don't know exactly where it is. All right. What is the name of this function? What's the name of this function, guys? What do you think? X to what power? Third. Now, I'll give it to you in just a little bit. It is a third, but take a look. Did I start it in the negative position or did I start it in the positive position? positive, and it's an odd, so y is equal to actually negative. Your leading coefficient is going to be a negative. It's opposite of what you think, right? Okay. Good job, Mr. Kate Smith. There we go. All right, let's go ahead and name this one. What's your domain? What's your domain? All real numbers. Your range. What's your range? All real numbers. In behavior, limit x to the negative infinity. Is that the left side or the right side? Is that left or right? Left. All right, so I'm looking at this one right here. Am I falling left or am I rising left? Rising. So y is going towards positive infinity, right? Because I'm rising. Okay. Limit going toward the positive infinity. All right, so am I talking left side or right side there? Right side. Look at your right side. Are you falling down or are you rising up on the right? Falling right or rising right? Falling. So what's falling? Negative infinity. Did you guys see that? Okay, see how I'm falling right? Negative, rising right, positive, right? Everybody good so far? X-intercept. Oh, you got a bounce right here. That's a bounce, right? And there's a cut. That's why it's x to the third. Okay, what do you think it's bouncing? This is what? -1, -2. How many times is it touching -2? -2, what? 0. It's doing it twice because it's a bounce. It's a multiplicity of 2. Remember I said that? But right now you don't need to worry about that. So, all right, what's another place it's crossing? Right here. What do you think that is? What do you think that point is where it's crossing? 2, 0. Who is saying 7? I know it's not Daniel. Oh, okay. I was about to say, it's got to be Daniel. You can't take that away from Daniel. That's 7. Yeah, you know, we can't take that away from Daniel. All right. Y-intercept. Where are you guys crossing the y-axis? Right there. What is that point? 1, 2, 3, 4, 5, 6, 7, 8, 9. So how do I write the y-intercept? How do I write the y-intercept? 0, 9. All right. Okay. Next part, relative maxes and all that. Is this point right here a relative max or a relative minimum? Minimum. What's your relative minimum? -2, 0. All right. Now let's talk a little bit about relative max. Is there a relative max up here somewhere? Yes. Do you know exactly what it is? No. I can't tell from this graph, right? Do you have an equation to tell you what it is? No. Just say there's one relative max, but you don't know what it is. Okay, so just write there's one relative max, but you don't know what it is. Because I don't have a function to tell me what it is. And this thing could go all the way up here and then down, right? So you would be guessing. Just tell me there's one relative max. Sounds good? Because we don't want to know. We don't know what it is, so we can't say what it is. What do you guys think? Not too bad? All right, let's go to page 4. We're going to use a calculator this time. I'm sorry, page 3. Yeah, page 3. All right, we got time. Okay, guys. Here we go. You guys got a graph right here? I think I put yours on top. Start down here, and then it's going to curve up something like this, right? Okay. If you don't have a calculator, come grab a calculator because you're going to find some points on here based on what you guys got. Calculator. Anytime you have an equation, a function, yeah, use those first. All right, everybody got a calculator? Okay, clear your calculator. Get off your phone, Ty. Clear your calculator. Oh, the calculator sounded like that, man. Okay. All right, you guys ready? Okay. Here are things that you can tell without a calculator. You don't have to do anything right now. What is your highest degree right here?